Welcome students. In your first class, I'm starting this first chapter, relation and function. Here we need to cover this 4 topics. So today I'm starting the types of relation. Before starting the types of relation, we need to recall some definition. First of all, Cartesian product. What is Cartesian product of two sets? If A cross B is the Cartesian product, then the elements of A cross B is ordered pair A comma B such that A belongs to the set capital A and this element B belongs to the set capital B. Now why I'm telling this is an ordered pair? Because it maintaining a proper order. That is, the first elements belongs to the first set and the second element belongs to the second set. Now here is one example is given. You can check the example. What is relation? A relation R from A to B is a subset of this Cartesian product A cross B, defining or taken out in some manner. That is, R has a proper manner or some proper definition. Here I'm choosing these two examples. Here, first is x plus y is 6, where x belongs to the set A, that is 1, 2, and y belongs to the set B, that is 5, 6. So you can easily check if 1 plus 5 is 6, so only there is one element 1, 5. So first relation is empty relation. I'm considering your class, that is students of your class from your school, and I'm defining the relation age difference between the students, that is x and y, is more than 25 years. Now you can easily check that age difference between you and your friend is definitely not more than 25 years. So the elements of this set are phi, which belongs to this Cartesian product A cross A. Now here is the proper definition. No element of the set A is not related to any element of set A. Again, I can take another example to clear the concept. These 3 elements are there, and here I am defining the relation is x plus y is equal to 10. If you check this ordered pair here, 1 plus 2, 3, 2 plus 3, 5, 1 plus 3, 4. And all this are not equal to 10. So here also we can see this relation is empty. That is phi belongs to this Cartesian product A cross A, hence it's the empty relation. Next is universal relation. Again, I'm considering the students of your class. And here the relation is age difference between the students x and y is less than 5 years. Now you can also easily check that between you and your friends, this age difference is always less than 5 years. So here R is A cross A. Why? Because every student is related to each other. That x comma y belongs to this Cartesian product, where that is each and every element of the set A is related to each other. Here is the definition. Every element of the set A is related to each other. I can check another example. A is equal to A comma B. So what is this Cartesian product A cross A? A comma A comma B, B comma A, and B comma B. Now here you can check this relation R. A comma A is here, A comma B is here, B comma A is here, B comma B is here. Hence, I can write A is equal to this Cartesian product A cross A. That is, all the elements of this Cartesian products are present in this relation R. Hence, this is a universal relation. Next is reflexive relation. What is reflexive relation? If a relation R is in a set A, it's reflexive if this kind of element A comma A or 1 comma 1, 2 comma 2, 5 comma 5, this kind of elements should be belongs to this relation. For every A belongs to A. Why for every A belongs to A? If we consider a set with 4 elements, 1, 2, 3, 4, then 1, 1, 2, 2, 3, 3, and 4, 4. These 4 elements should be belongs to the relation. If these 4 elements are belongs to this relation, then we call this relation is reflexive. If one of this element is missing, that is, suppose this 4, 4 does not belongs to this relation, then we can't say this relation is reflexive. That time we call this relation is not reflexive. Another example you can check. A is equal to 1, 2. Here 2 element is there, then 1, 1 and 2, 2. Should be belongs to the relation. For verifying this reflexive property, so here you can check 1, 1 and 2, 2. Both are present in R, hence it's a reflexive relation. Here it is given. But check R1, 2, 2 does not belongs to this R1, hence it's not a reflexive relation. Here is another example is given. You can check this example also. It's a symmetric relation. What is symmetric relation? Suppose this person A and this person is B belongs to any set. If I change their position, then if also this pair is belongs to this set, then that time we call this is a symmetric relation. In mathematical language, we can say that AB belongs to this relation, and it will imply that B comma A, that is, if we interchange their position, that also belongs to the relation R, then we say this relation is symmetric. So this is another representation of symmetric relation. I'm taking here a set A, 1, 2, and 3. Check the first relation R1. I'm writing this 1, 1. If I change their position, it will remain 1, 1, 2, 2. If I change its position of these elements, it will remain 2, 2, 1, 2. If I change the position of these elements, that will be 2, 1, and 2, 1 will be 1, 2. Now you can check these 4 elements are belongs to this relation R1. Hence, this AB belongs to R and BA also belongs to R. This condition is satisfying. This is symmetric relation. Now for R2, we can check 1, 1. That will be again 1, 1, 1, 3. If we change their position, that is 3, 1. 1, 2, this is 2, 1. 2, 1, this is 1, 2. Now check, this is 3, 1. This 3, 1 does not belongs to this relation R2. Hence it is not symmetric. Here another example is given. You can check this example also. Check it by yourself. Next is transitive relation. Suppose this person A and B belongs to a set and B and C also belongs to the set. These two pairs are belongs to a set S, or you can say in a relation R. Now if A and C, that is the first person and the third person, ordered pair of this first person and the third person also belongs to R, then we can say this relation is transitive relation. So in mathematical language, I can say if A comma B and B comma C belongs to the relation, and it will imply that A comma C also belongs to this relation. That is first, second element, second, third element, and first, second element should be belongs to this relation. That time we call this as a transitive relation. So take any example. Here I'm taking A is 1, 2, 3. Now check the first R1. Here 1, 2 I'm taking, and 2, 3. So first, second, second, third. So 1, 3, if it belongs to the relation, then it's a transitive relation. You can check for 1, 3. It also belongs to the relation R1. You can check this transitive relation for each and every element present in this relation, and it will be a transitive relation. Now for R2, 1, 3 and 3, 2 belongs to R2. Now first, second, third. Now first and third, 1, 2, it does not belongs to R2. Hence, it is not a transitive relation. Here another example is given. Check it by yourself. Next is equivalence relation. If a relation satisfies this three property, reflexive, symmetric and transitive, that is A comma A should be belongs to the relation. A comma B is present, then it will imply B comma A also in this relation, and A comma B and B comma C are present in this relation. If it is imply that A comma C also present in this relation, that time we can say this relation is equivalence relation. So here is an example. You can check the reflexive property 1, 1, 2, 2, 3, 3. 3 elements, these 3 pairs are there. 1, 2, 2, 1, 2, 3, 3, 2, 1, 3, 3, 1. This is also belongs to this relation R1. Now 1, 2, first, second, 2, 3, second, third. So 1, 3 should be belongs to the relation R1. So here I can check this 1, 3 belongs to the R1. Hence it's a equivalence relation. Next, some homeworks. Here is this 4 relations are given. Here you can check this relation is reflexive or symmetric or transitive. Okay, you can check this problems by taking their elements. For this one, I can say this A and B belongs to the set 1, 2, 3, 4, 5 and 6. So A comma B pair should be, if A is 1, B is 2. If A is 2, B is 3. If A is 3, B is 4. If A is 4, B is 5. If this is 5, then it is 6. Now if A is 6, then it is 7, which is does not belongs to this relation. Means this relation does not belongs, this pair does not belongs to this relation. Hence 1, 2, 3, 4, 5. Only this 5 elements belongs to this relation. Now you can easily check this is reflexive or symmetric or transitive. So any problem or any queries is there, then you're free to ask. Thank you.